to the cloud. Okay. Well, welcome everyone. My name is Andy Lindsay, and I am going to switch to screen share and show you some things about the microbit today, particularly some tips for teaching with the microbit. So here we are at the cover slide. And again, please, everyone, feel free to just, if you want to jump in and say something, unmute yourself.
Andy, the thumbnails are up again.
They are? Oh, okay. I shared the wrong screen. Thank you. Let's try this again. Share. All right. How does that look? Okay. So this is the Granite School District microbit PD, where we're going to talk about implementing the microbit in your mainly junior high level classroom. My name is Andy Lindsay from Parallax, and a little bit about this cover slide. Normally, I'd include just some sort of single summary picture of what to expect, but one of the things I did here was I picked some excerpts from microbit.org/project/make-it-code-it, which we're going to be spending some time on later this afternoon in the 2-hour workshop. But I wanted to include some of this up front just to kind of give you an initial idea of hey, here's a little programmable device. It has a microcontroller that you can write code for on your computer and load into it to make it do things. And there's a lot of things that are interesting to young people that you can do with it. And so starting out here with, this is just a list of some of the projects that we're going to look at later. So there's just simply displaying a heartbeat. That's using this little display here. There's an emotion badge that's using the display for a smile or a frown. And then students are encouraged to add some other emotions from the list. But there's also push buttons here that they're using to choose those emotions. And again, they're writing code and loading it into this device to have it do that. It has all kinds of built-in stuff. For example, it can sense light levels. It has an accelerometer in it. That's a device that can sense tilt and acceleration. It's actually got 3 axes, and so it can tell what its orientation. You can programmatically, with a script, figure out what your orientation is in space. And so a step counter is one of those applications, along with dice and Magic 8 Ball and various other games where you can just shake the microbit to make it do something, because the accelerometer will detect that. It has a built-in compass, and it even has a built-in radio so that you can zap messages from one microbit to another. So it's this really neat device. There's a lot of fun stuff for young people to do with it. And so that's why I chose all these little pictures here for this cover slide. A little bit about myself. My name is Andy Lindsay. I've been an applications engineer at Parallax for 21 years. My education background is in electrical engineering, but when I landed at Parallax, I started writing educational textbooks for them, in addition to teaching groups of teachers how to use educational kits, helping develop educational kits, supervising the hardware that's created, like this robot right here, the blackboard that's on top of it. I collaborated on that. And so most recently, my emphasis has been on the microbit. So I started by extending a group called cyber.org created a book for this microbit powered robot. And what they did was they did a derivative work of a book I wrote similarly for a similar looking robot that has the Arduino processor on it. And so my first thing after being part of the development team on this robot was to write some cybersecurity material for it. And just in case anybody's interested, you have the link to the slideshow, but I also have to remember to share out that link. Whoopsie, file, share, and copy link. All right, and then let's see if we can get to the Zoom controls here. Chat. Okay, here you go. This is the slideshow, slide deck. Okay, got to make sure to hit all the keys. All right, so that is a link to the slideshow. You're welcome to open it or just follow along in the screen share. So this is the Cyberbot, and there's lots of links here. So for example, I'm going to quickly open the online workbook for the Cyberbot. And the reason I'm doing this is just as a quick pre-emphasis that for those of you who are looking into teaching Python, that these are all Python lessons here with the Cyberbot. And we're also working on the graphical programming language, the make code blocks programming language for the microbit. But currently, I just wanted to mention that there is a wealth of Python information. There are 2 flavors of Python, and I'm going to be emphasizing that the Python that the Microbit Foundation created is if you're going to get familiar with either of them, in most cases, it's going to be that one. And I'll come back to that later, but I wanted to mention that quickly now, and that simply there's all kinds of links that you can follow here. Just as we're recording this workshop to make available for viewing in the future, there are YouTube workshops of the most recent Cyberbot PD workshops here. And then another one I've been working on more recently is an electronics kit, where we have a similar thing. You can go to the product page. There's online workbooks for it. There's educators' resources for it. And we'll be talking more about educators' resources this coming Monday. And then also the most recent Zoom workshops on YouTube. And so we try to do that for pretty much everything we do. A little bit about Parallax, where I work. We are kind of dartboard center of California in Rockland, just outside of Sacramento. So between San Francisco and Lake Tahoe. We've been around for quite a while. I'm going to switch over just very quickly to another slideshow. Microcontrollers are the brains that are inside products that you use. Many different, you interact through various products that have buttons and displays with many different microcontrollers in a given day, but microcontrollers can also be programmed and talk to custom circuits of your creation. See if I can get my slideshow back. So Parallax and its chief inventor, Chip Gracie, invented the Basic Stamp 2 in the mid-90s, and it pretty much changed. It took microcontrollers from being an engineer-only thing to being something that hobbyists and educators and students could do. So Parallax did a lot with that, and we made a series of robots. We've made all kinds of educational kits and textbooks. And Stephanie and I have worked together on that, me as lead author and Stephanie as technical editor. And so things just continued to expand at Parallax. Like, for example, the small idea of sensors here to connect to your microcontrollers became an entire line. And microcontrollers also proliferated. And so now here we are back today at having this building with folks working in it. And I am actually right behind this window right here, presenting away right now. And so that's a little bit about parallax and our history with microcontrollers and education, since we were, made the first easy to use microcontroller that you could connect to circuits and program. A little bit about today. So today, the main goal is just to get familiar with and comfortable with the microbit. I've already talked a little bit about things it can do, and we'll talk more about that. Want to get you all off to a healthy start with the microbit. Probably one of the bigger challenges with getting started teaching it is just to settle on a language and a platform. So I'm going to be talking about the most popular languages and platforms that are available for the microbit. And hopefully you'll have some questions at that time. There's a lot to choose from. And so the best thing to do is to match what's available to the learning outcomes you've got for your students. And then we'll also do some applications to make sure your microbit is working for you, because when your student gets stuck, some of that hand-on experience is going to be really important. Okay, everybody, how does that sound? Are we good to continue? Okay, I'm getting some nods. Thank you. Excellent. All right, so what is the microbit? I've alluded to it already, but so it's a device you can program. I like to describe it as kind of a microcosm of the kind of programming that happens with a cell phone. On the microbit, you've got a display, just like with the cell phone, you've got a display, you've got buttons, you've got a processor, there's a built-in radio in it. And then, most cell phones have GPS. Well, as a microcosm of that, we have our compass and our accelerometer built in. And then this little USB port here is where you can load programs. With the microbit 2.0 that you have, you can also load programs over USB, but I did not think in 2 hours it would be a good idea to add in that potential tech support gotcha. So we're going to all use USB cables with our computers. It also has a touch sensor, a microphone, like a cell phone, a speaker, again, like a cell phone, and then a battery socket, which I guess, could be akin to your recharging. Unlike a cell phone, there are also electrical connections available so that you can actually clip on alligator clips to these large pads and then connect circuits to them. And so there are a number of examples of that sort. There's also some small metal pads that can be plugged into adapters, and then you can make a cool robot or a cool electronics kit. That reminds me, I forgot to mention the other kit. So I'm currently working on a Learn Electronics with the microbit kit, and it has some included measurement software that behaves like common electrical measurement devices, voltmeter, ammeter, ohmmeter, and those kind of things, and then a similar set of workshops for that. Back to the microbit.
And
yes.
I'm going to pipe in there. Folks, I participated in that electronics workshop as well. And Andy's going to show you some of their other trainings and things. It might be something else, especially those of you that are doing some of the tech ed type programs. That might be another element that you want to look at individually for your separate spots.
Yeah, and so I made sure to mention it up front here, partially just to kind of give you an idea that the microbit can be a thing on its own, as we're going to treat it like today, but it's also something that you can use to grow into additional projects and courses. Thank you for mentioning that, Ed. Okay, so let's see if there's anything else on that page. By the way, whenever I have an image captured from a site, and most of these are going to be from the microbit.org site, I try to include the link so that you can follow it, and it's nice to have a reminder. And so this link is pretty important because it goes into more detail about each thing. Like here's the buttons and the 25 LED display, and you can follow links on each of those to learn more about all these features that are on the microbit that students can use and mix and match and combine to make their own inventions. little bit of history about the microbit. There's a nice long article that I really like on Wikipedia. And then Microbit also has their recounting of the history. They're both great reading. But I think the high points are that the BBC started a Make It Digital campaign a few years back. And for that, what they did was they had manufactured and distributed to schools at no charge 1 million of the original microbit modules. And so students got to start playing with it, learning MicroPython and learning just about digital devices and coding in a fun and unique and interesting way that had not been done before. The microbit version 2 came out recently, and in addition to all the other cool features that they already had, they added a touch sensor, speaker, microphone, and some additional programming space. And again, we've got links you can follow for more information on all that. To get started, I would like to follow the path that Microbit prescribes for anybody who arrives at their site just by going to microbit.org. And I'm a little bit into the get started here. Let's see here. Okay, so this is the landing pad. If you go to microbit.org, and then we've got first steps right here, and lo and behold, we end up at the page that I jumped to from the slide. So these really are the first steps. And so the first steps, as they call them out, are program, connect, and then transfer your program from the computer to the microbit. There's going to be 2 ways to do that. One is a drag and drop way, and they have a nice little video about that for, if you're back here later or at another time. And then they have another for actually connecting your browser to the microbit, as opposed to, well, I'm getting ahead of myself. So basically there's 2 ways of getting a program into your microbit. And one of the things that's really great about the microbit is that it's the easiest one to get up and running of any microcontroller in education that I'm aware of. And you'll see that in a few minutes. We're going to do a few virtual things first. And so that they have a drag and drop method where the microbit behaves like a USB flash drive, but then they also have a direct flash where you connect your browser to the microbit, and then it transfers the code. And they also have a mobile app, but again, in the interest of time, we're going to skip that today. If anybody wants to talk with me about that offline, we can look into it further. All right, so there is a link here, and I should share this link. I just want to make sure it's also in the, okay, so this is first steps page, paste, and checking the comments. This is from Ed. Ed, you won one of the Bobot robot kit? Whoa. Okay. Yeah, I don't know. Do you want to talk about that, Ed? You're muted. Sorry.
I actually won that in Nashville a few years ago. So I have 10. It's a 10 unit or 10 robot kit that I haven't facilitated yet.
Wow.
It's one of my resources. And so that's another one that hopefully will find a use for them. So.
Okay. Yeah. Feel free to get with me on tips for the Bobot robot. That's another variation. Let's see here. Have 2 new messages. 24 cyberbots. Okay, so we have great cyberbot resources for you, and trainings will be scheduled too. So, yeah, for those of you who have acquired or received or are purchasing cyberbots, and yes, we are in the middle of a global supply chain kerfuffle. And so we're working to the best of our abilities to get everybody their robots. It looks like it looks like Kurt is maybe waiting on 12 and received 12. And then, yeah, you can get with me on that. I might have some tips for you offline.
They're floating somewhere and out there in one of those oceans, right?
That could be in one of the container ships. Yeah. Yeah, we have been really busy making, doing what we can to make sure that teachers can still get kits, because boy, there's a lot of stuff that disappears, and it's quite the scramble on the engineering and evaluation end to make sure that substitute parts are okay. All right, so on the program, taking their prescribed first step, it's not the only entry point, but it's a pretty nice one. We're going to go to the Let's Code page next. So Let's Code page. I'm calling these out and putting them in the chat. We'll put the chat up with the, well, possibly an edited portion of the chat, but we'll put the links that I share up with the video. So going to the Let's Code page, there are two main options. There's the Microsoft Make Code Editor and the Python editor. Since the Make Code Editor is kind of a lowest common denominator editor, we'll start there. This Python editor right here is the one I mentioned earlier. Because Microsoft has a Python, but the Microbit Education Foundation, as in microbit.org, also has a Python editor. They put a lot of love into this. It's a really great editor, and it is the one that we used when I showed you all those tiles for the Cyberbot and the student workbook near the beginning of the presentation. This is the editor that we use for that. But for getting started, we will use the Make Code Editor. So I'm going to open that into a new tab. And I'd like all of you to do that too. And probably what you'll see if you have not been here before is new project, but none of these tiles to the right, because these are all just code that I've worked on recently. And then hopefully you'll all see the tutorials and everything else. So are we all there? Okay. All righty. And then unmute yourself, shout stop, or if you chat stop, hopefully Stephanie will see it. Let's see here. Yeah, because I am not seeing all I think I am now seeing all attendees. Let's see. Is Stephanie still here? She may have.
I'm here.
Oh, good. Oh, there you are.
Yeah.
Sorry about that. All right. Okay. So, and then of course, if you're new, here's the start here thing. And many of your students, if you set them up with a list of pages to go to, this is a great starting point. So let's go to this new start here thing. Again, first I'm going to copy the link. I can't. Okay, I'm going to open it and then copy the link. Flashing heart. Okay, when I click flashing heart, we have a choice of blocks, Microsoft's Python, which again is not the Microbit Foundation's Python, and JavaScript. I'll come back to these. Let's start with just blocks, and we can start the tutorial. And so the screen that comes up is basically showing us, hey, this is what it looks like when you're done. So you're going to have a graphic of a heart that appears and disappears, as in it's like a beating heart. And so once you're sure about that, we can go ahead and hit OK. There is also a video you can watch to learn more about how it works. I'm going to leave that to you guys for your free time, and just hit the OK link for now. And what it's showing here is that you're going to click the basic category of tiles, the basic class of tiles. And from that, you're going to grab the show LEDs, which allows you to select which LEDs are turned on and off. And so I'm going to do that as a demo. Place the show LEDs block in the forever block and draw a heart. So click basic, select show LEDs, place it in the forever block and draw a heart. Just like they did. And they also emphasize that if you make a mistake and click too many, you can click again to turn it back off. So there is our heart. And notice over here that there's a simulation on the left. So I want to wait now and make sure that everybody is caught up with me. I'd like you all to do this. So give me a thumbs up when you're through with that. All right, way to go, folks. Gonna wait for a few more thumbs ups. Guess I can't see them all. Excelente. Have we all got it? All right, looking good. And again, unmute yourself and shout stop if there's a problem. So now it says, so we can go to the next step. And the next step is place another show LEDs block, and you can leave it blank. Now, if it were me writing this, I would have said place another LEDs block below that first one in the forever thing, but hopefully everybody gets that. So we're going to take the show LEDs block and then just click it below the first one that we did. And now our simulation on the left is showing us that the heart lights are turning on and off, which is a really good sign. So are we good? All right. So what is the next step? I don't remember. Okay, look at the virtual microbit. You should see the heart drawing blank. Check. Okay. If you have a microbit connected, we don't yet, but we will soon. Click download to transfer your code and watch the hearts flash. And I'll add parenthetically in real life. But before we do that, let's click finish here. And let's look at what we get when we're finished, because the display is going to change from the training wheels list of classes to the to everything you can do with the microbit. Everybody see that? Excellent. Now there's some really neat stuff, and I want to dwell on this before we even connect our microbit, because there's some great stuff you can do. Like this middle button here. It looks kind of like a bug. And it's actually for debugging. So if we click that, we get our entire debug. I have somebody knocking at the door. One moment, please. Yes? Okay, apparently not. All right, so with this, we can, for example, step using the step button to go from to basically see how the code execution travels through the blocks. Here we have this on start block, and then we also have the ability to step through the program steps. These little holes right here are to set breakpoints. But before I do that, I'll just run it. So when we run it, when I hit run, that little green triangle button, when I hit run, it just simulates at full speed. If I hit pause, which is what run becomes after you hit it, it stops at whatever step it's on. Some fun things are you can do it in slow motion so that it shows you, and that's the little snail, so that it shows you which block is getting executed. Now, additionally, you can set a breakpoint. So that's these little circles in the upper left of the show LEDs tile. And so if you click the bottom left circle, or the circle in the lower of the two tiles in our repeat forever block, and then hit run, it's going to stop at that breakpoint block, and you can hit run again, and it'll continue executing until it reaches the breakpoint block. You can also use step. And then clear the breakpoint by clicking it again. So that's a pretty powerful tool, I think, for helping students understand how code is being executed. Does anybody have any questions about that currently? Or did it just work and we're ready to move on? I'm fine either way. All righty. Okay, good. So let's go ahead and close the debug mode. Are any of you teaching your students JavaScript? Or is there a possibility you might? Okay, so how about if I just show it to you for your information, but I'm not going to take very long on it at all. So don't worry about following along with this. I'm just going to whiz through it just to show you very quickly. Okay, so right now we're in blocks view. Well, there's also JavaScript and Python view. Again, this is not the Python you're looking for in most cases. Here is the JavaScript. So I'll go ahead and choose it. And what it did was it took the code I wrote. See if I can zoom in on that. There we go. So control scroll wheel does not work for this, but control plus repeatedly does. And so this is what the JavaScript for, and this is actually TypeScript, which is just JavaScript with a few more formalities added. But this is, you can develop code here too. For example, I can say let n equal 0 up here. And I could potentially say something like n equals n plus 1 here, and even display n, but I need to go back to the blocks view. Now notice that it added a block that we didn't have. It actually recognized that the JavaScript I added, it did give an equivalent of what that is in terms of blocks, which is very impressive in terms of a virtual system. And so let's see here. And I want to display that. So that's basic. And then we want to show a number. And then the number is going to be in variables, and that number is named n. So I'll drop n right in there. And so if you wanted to get the set n to n plus 1 block, that would be basically in variables. You could make a variable and you'd name it n. I'll just give myself another variable called m. So so M appeared, and then basically they have these blocks where you can set the variable to a value. So for example, where'd my initialization block go to? That's funny. Okay, on start is the other block. So I can set, this is just, again, this is for your information. We'll do some more with this later. So I'm just quickly going through and saying, okay, well, we'll set n to 0, then we'll add 1 to n and display it. And if I run that simulation, darn. Wonder if I made a mistake here. Okay, so I'll, yeah, my simulator is stuck.
Too many tabs open?
Do I have too many tabs open? Well, that's quite possible.
Maybe the bandwidth for the presentation.
Yeah, it's true that the video presenting definitely can slow down your browser. Yeah, I'm just going to have to bite the bullet and, oh, okay. Well, actually, while we're here, let's see if I can save my work. So let's do flashing heart. So see this little thing down here, this little field where it says flashing heart. Well, we want to modify the name. So for you guys, you know, maybe you could draw just a small little heart. As a modification. And then we'll call it flashing heart.
So Andy,
mod.
I have a quick question before you go too far.
Oh, of course.
You just kind of, you know, browsed over the Python part of the.
We'll go back.
I mean, I'm just saying, I know you said it's Microsoft's versions of Python and you kind of dismissed it, but it seems like we could do something similar just using the Python.
Oh, absolutely. If for the basic coding, again, I did say this earlier, or I hope I said it. Maybe I just said it in rehearsing before the presentation, but it's going to come down to what works best for the learning outcomes that you have for your students. And so that may well be initially starting off with Microsoft Python. One heads up I just wanted to give everybody is just that there is the microbit.org Python came first, and there's quite a tremendous amount of resources that are available with it. So I want everybody to be able to work with it. And so, yeah, this
just more that once you built the blocks, I don't think it hurts to just say, hey, take a quick look at it in Python.
Oh, yeah.
and see what you recognize. And I also think instead of using the set block in the forever loop, you have to use the change block in there. I don't know if you can use a set in the forever and a set in the on start.
That could be. Maybe that's why my simulation isn't working. Shall we try that?
But anyway, I was just gonna say it probably doesn't hurt to look at the text view once in a while with your kids.
Yeah. Let's see here. I'm looking for a way to increment a block.
Well, in the variables, there's a change block now that you've created one.
Ah. Interesting. Thank you. Okay, to get rid of a block, you can drag it over to the block classes / categories, and that makes it go away. Yeah, my simulator is still not responding. We'll get back to that though. So I just called this flashing heart mod 1. And then there's a little save icon. And when you save it, what it does is it downloads a hex file. And these hex files you can use to basically they're your students' work. And so so this should contain all of this right here. And interestingly, after I saved it, it came back and started simulating. And I don't know why that is. I'm sorry for that. But I get the impression that maybe I needed to save my work before the simulator could return. Now, I shouldn't have been dividing by 1. I should have been, oh no, that is the plus. Okay, change m, wrong variable. Change n by n plus 1. Okay, 1 beat, 3 beats. So we got a nice little progression of large numbers. So
yeah, I just removed that purple option and just said n by 1.
Thank you. Like so?
Yes.
Okay. Yeah, I think I took a little bit too much of a lead by what they gave me for the Python or for the JavaScript I put in there. All right, so trying this, I'll save it again. Hopefully that'll unfreeze my.
Mouse. There it is.
Okay, so simulation wise, I'm pretty happy with what's happening here. Then we have the JavaScript version of what's happening. And we also have the Microsoft Python version of what is happening. The syntax, just another heads up that the syntax is also somewhat different from, fairly considerably different from the syntax you'll see. Both use MicroPython syntax, but the way a program works here is a little different. For example, this right here is a formality that is not normally used in the microbit's version of Python. And so, yeah, there's similarities. It all boils down to JavaScript or TypeScript, regardless of which programming language you're using in this editor. And here we are back at blocks. All right, now, if I make some kind of drastic sweeping change to my program, wait a minute, gonna say mod 2 and hit save again. And it's gonna download, I'll have another download here. These are all in my downloads folder. So right there. And okay, so if I change something like throwing out all these blocks, well, now nothing's happening. But if I want to get back to my old work, in most cases, you can just drag a file onto the editor that one of the files you saved. Another thing you can do is do that from your file browser. You can drag a file, one of the files you saved earlier, and it will show you. So this was a broken version of the file that I had. And then this is the most recent working version. And thank you, Deborah, for getting me back on the right path there. Okay, so how are we doing with that? Is that enough on the make code editor and the simulation and the different language options that are there? All right, so let's see if we can make this work now with our microbit. So could somebody who still has their box hold it up so that we get a recording of what the incoming box looked like? I just have my mic actually. Okay, looking good. So we've all got our boxes, and in there you'll have a small USB cable and then your microbit. So those are the things that we'll want to get out of the box. And go ahead and connect your microbit to your computer once you get it out of its box and its little gray plastic bag. And it'll make a racket and it'll show you all kinds of display stuff.
It's actually got like a game on it, doesn't it? That you can play to test different things out.
Yes, I did see something about an Easter egg, and I think I still have that page up because I only restored this to the okay. So I've been using this microbit and I just restored it to its defaults. And you can press A+B to, that's not the Easter egg I'm looking for, really. All right, so I think that, let's see what happens when we press A+B. First of all, I'm going to mute my own video and then start up my other webcam. All right. So if I press and hold A+B, okay, so that's A, and then B. Okay, so they want me to shake it. All right. I don't know if that was visible, but it said shake. Okay, and now it's saying shake it again. And now what? Okay, so if you find out anything more about how to get to the, I'm shaking it because it's telling me to. Okay, so I don't know how to get to that Easter egg. If anybody finds that, go ahead and give me a shout out and maybe paste it into the chat. Otherwise, I'll see if I can check that and give you the Easter egg recipe for next time. All right. Going back to let's see here. Okay, so back to the video. We've all got our microbits now connected to the USB port. All right, and then when you connected, in addition to all that stuff that the microbit did, hopefully a file browser opened for you that says microbit E, so it should look like a flash drive. Okay, if everybody has microbit E, make sure that you can see the contents of your microbit, which is just going to be details and microbit.htm in your file browser's contents pane. And then at the same time, we want to be able to see our downloads. So whether that's basically one of the downloads that you, one of the files that appeared when you hit save, or whether it's your actual downloads folder. Either way, the trick to loading a program into your microbit to make it actually do that heartbeat is to drag that hex file that was downloaded and drop it onto this virtual flash drive here. And it will show that we're transferring the data. And if everything works out, we should start seeing when done, when this is done, the heartbeat should appear on your microbit. And then the explorer for the microbit will disappear and then reappear without the hex file. But so that indicates, at least on the screen, that everything worked out. And so moving to my microbit and resuming the live image. Yeah. 14 heartbeats, 15 heartbeats. It's not actually correctly visible. Let me see if I can just change the tilt. Does that do it? All right. So it is displaying a heart, but the way it's flashing the LED lights, the heart is not displaying very well on my camera. But hopefully, does anybody not have their heartbeat showing physically on their microbit now? We've all, okay. So you do or do not have the heartbeat? You have the heartbeat. Okay, good. Okay, so again, just stop me if I'm plowing forward and you're needing help getting your heartbeat to show.
My heartbeat is not showing. I'm not sure if I missed a step or something. This
Okay,
is Alan
let's.
Crookson.
Okay, Alan, thanks for stepping in. Let me review. So first, what you're gonna want to have is I'm looking for my, here we are. So the first thing is check your code on the simulator. Were you able to get some kind of heartbeat running on the simulator with the code that you had?
Yeah, I have a heartbeat flashing on my simulator.
Okay, perfect. So the next step then is going to be to download that. You can either hit save or you can hit download.
Okay. I don't think I downloaded it.
Okay, now when you download it, it should appear on a bar along the bottom of your browser. And ideally, we all want to be using Chrome browsers for this. For not now, but as in it's not needed now, but for a later step, having the Chrome browser is going to be important. Okay, so once you've got it downloaded, then the idea is to go back to your file browser that shows you the microbits contents.
Mm-hmm.
So that's this. And then you can basically drag that file from the downloads ribbon at the bottom of the Chrome browser. Whoa, I didn't do that very well, did I? Let's try this again. I think I got to start moving it. Nope. Okay, so this is also so one way to do it is to open your downloads and drag it from your downloads folder into the microbit drive, or you can drag it from where it appeared in your browser downloads and drag it into the microbit drive. And it should show a file transfer, which will take several seconds. I'm guessing 10 to 15. And then once it's done, the microbit drive should disappear and then reappear. And at that point, if we look over at our microbit, the activity should appear. And again, it's not catching all the pixels on mine.
Okay, yeah, it's working now.
Excellent. Excellent. Okay. So that's really good because it means we've all got our programs loaded. That is one of the 2 ways to load code into your microbit. There's another way to load code into your microbit, and that is there's 3 dots next to the download button here. And so click those 3 dots and select connect device. And it will tell you to make sure that you have this USB connection in a picture, and we all do. So let's hit next. And pair your microbit to the computer by selecting BBC, microbit, CMIS, DAP, or DAP link from the pop-up that appears when you press next. So I'm going to be looking for one of those 2 labels, either BBC microbit, CMIS, DAP, or DAP link, CMIS, DAP. When I click next, there should be a pop-up like that. There it is, microbit, CMIS, DAP. So you've got to click that. You can't just hit next. You have to select your microbit and then click connect. Okay, let me see if I can disconnect and well, let's see how you guys do with that.
This is what I usually use with my students, just because they have Chromebooks and the whole like E-drive and other stuff, just they get confused to download it, put it on. So I just tell them to connect and download that way.
Yeah, most of the tutorials, even with the Cyberbot and that electronics kit, we do the same thing. We just have them connect. It's a lot quicker. And okay, so so it sounds like you folks are more experienced. Some of you have already been using the microbit in your class, and I just ran into a hiccup because I thought I knew this, but looks like it might be a little different. Is it correct that now when you click the download button, it flashes it to your microbit? I'm getting 1 nod. Yeah, it looks that way to me. Let me see. I'm going to this is kind of an interesting test that you might need for troubleshooting some other time. I don't think it's really that important right now, but so if we're looking at the communication lights, my hope would be that okay, so hopefully the communication light right here is going to flicker when I hit download. Except for I got to get this over to the left. Download. So it's thinking, then this screen is going to kind of get a blue overlay look to it. And then try that one more time. Yeah, so it started counting at 1 again. I know that may not have been visible, but it did start counting at 1. So that is the way to load your code. The microbit editor has, it makes a distinction between flash and download. So download is when you download to your downloads folder, and then flash is when you load the program or the script into your microbit. Are there any questions so far?
So when that downloads automatically like this, you don't see that same hex file. Is that right? I mean,
That is right. That is absolutely right. And so when you're saving, it's kind of important to use that little floppy disk save button. So if you made a change and you loaded it into your microbit, and then you're happy with the way it worked, and you want to take a capture of that version of the program, I'll change it to microbit or flashing heart mod 3. You want to hit the save button. And as you can see now, it downloaded as opposed to going into your microbit. And I believe that, yeah, see, the 3 dots shows you that you're connected. You can also download it as a file, and that should just give me another hex file copy. It does. And then the save button is always there in case you want to save it. And there's also a publish to create GitHub repository thing, which I don't want to get into because that's going to take longer than we want to spend today. However, if there's any interest in any of the features I said I'm skipping, go ahead and let me know to try to fit it in on the next session. If if you feel like some of these are important, like loading code from a tablet or publishing your code to GitHub, things like that, I'm definitely open to adjusting the agenda for next time, because this is all about you guys. And so whatever is going to be the most useful in terms of topics covered, I'll do whatever you want.
Thank you, Andy. And folks, this is the opportunity. I realize some of us have been using them for a while. Some of us are new. And so this is really stratified in where we're at. But if there's anything specific that you want, make sure you contact Andy on that. Okay.
Yeah. And so hopefully you all got my email saying, hey, get a Chrome browser and your microbit ready. Go ahead and just reply to that and let me know what you have in mind. Otherwise, I will be focusing a little bit more on curricular resources next week. Those being ones that are provided by the Microbit Education Foundation, by Microsoft, by Parallax, and by cyber.org. So those are my main ones that I'll be showing you because they're all free. And if there's any actually that you've, for those of you who have been using this in the classroom already, if you have a favorite resource, by all means, bring it to my attention if you'd like to see it appear next week. All right, so that concludes the, well, actually I'm going to do one more thing, which is go back to debug and show you now that we can see the variable n. And I could even set a breakpoint here and then run it. Oh, sorry. I want it in snail mode so that we can see the execution happening, and we can see it stop at change n by 1. N is currently 0. When I step past it, n becomes 1. So these are really important things that you can have your students go through exercise-wise so that they can hopefully better understand how their code is working. And we can even refresh in snail mode. Now, unfortunately, one sad thing there is that it didn't show me, I didn't see it hit the on start. It just seemed to go straight to the loop. Refresh, snail. Let's see if we can, no. Yeah, it just sticks in the main loop. Okay. not perfect, but overall, I think it's just a fantastic little system for getting to understand the code better, in addition to having a cool little thing that you can load code into and make all these projects with. All righty, so going back to the slides. What I did also in the slides is I just made some notes about where we went and the things we talked about. Pardon me. Next, I'd like to talk about the, see how we're doing on time, 307, or it's actually 407 for you, 307 out here in California. And so the next thing I'd like to talk about is the Python editor. And this is, so we were able to look already at the Python editor that's in the make code edit system. And this is the Python editor that, so this is Python editor. At microbit at python.microbit.org. And then pasting the link. I'm actually going to do just a quick, hey, look at this for those of you who have already been teaching it. If this is all new to you, don't worry about that. But up here in the web address, notice that it says V2. Well, there is a V alpha. So this is V alpha right here. This is the new Python editor. All the same features, but one really cool thing is that you can create your own modules. A module is a library or a piece of reusable code that you can add to your program, and you can say, you know, from my custom module, import and, you know, a particular name or everything. And so, so it's going to expand what students can do with the coding. And so that's /v/alpha as opposed to /v/2, which is the web address python.microbit.org/v/2, which is the current editor. So the alpha is for evaluation and comment, and you can share your thoughts with them if you're if you've been using the Python editor already and you want to to take a look at what's coming down the pipeline. All right, so here is the Python editor, and it opens up with a default program. So let's go ahead and run that. Now you can download it, and it should appear right down here as microbit program.hex. And then you can drag and drop that into the folder to load it, or you can hit connect, and then download is going to become, oh, hey, you know what? I forgot to disconnect over on my other editor. Okay, and we might all need to do this. Anybody who connected with this, we need to disconnect. Okay, so over here in the Microsoft Microbit page, click the 3 dots and select disconnect. And it's saying to click on the lock icon and uncheck your device. So I believe that's hitting this little X right here. So that is the Microsoft way of disconnecting. Once you've done that, looks like to apply all your settings, you need to even reload the page. Fortunately, it keeps the code, but it would always be good to encourage your students to save. Then coming over to python.microbit.org, we can hit connect, and it gives us the same screen or dialogue that the Microsoft editor does. Now, once you've connected, download becomes Flash. And so you can, at that point, load your program into your microbit. And this is the default program, and it's telling you that it may take longer than the next time you download it. Pardon me, flash it. And the reason for that is because the microbit.org's Python uses a different Python runtime engine than the Microsoft one does. So it's basically erasing how the microbit interprets code and then reloading a different version of how the microbit interprets code. And so anytime you switch from one to the other, you will see that, gee, we're going to take longer this time to load code the first time. And there we go. And then, so for that, you want to see hello world, followed by a heart, displayed for 2000 milliseconds, which is a total of 2 seconds.
You know, I might be just a little bit behind, but I pushed connect and it just says disconnect now. So I'm assuming it must be connected.
It is now connected, yes.
Okay, and then you said we had to do what after that?
Flash.
Okay, that's the stuff I missed.
Yep. Thanks for making sure that you're with us as opposed to
So
quietly.
our students would have to do that one time or every time they came back to this browser?
Okay, so if they use the Microsoft browser in between using this, okay, so there's several different ways to think about that. Let me think. So one thing they could do is they could disconnect here, go back to the Microsoft browser and connect, or, you know, anytime they load a program from the Microsoft browser is going to put its runtime on there. And then anytime they come back here, if you hit connect, it takes a long time, but if you download and then use this, it's actually doing that same longer process. When you download a hex file and then drag it and drop it into your browser, it takes longer inherently because it is copying over in this case, the MicroPython runtime. So when I drag it in, it's still taking a little bit longer. And the reason for that is because when you load a hex file in by dropping it in the USB drive, you're getting the entire runtime along with it. But when you use connect, now that it's happy that it has the runtime, when you flash a modified program, the flash goes really quickly and done. So, so that's the advantage, and that's actually similar to what happens in the Microsoft editor too. Is once you're serially connected, all it does is incrementally update the script that you have in there, and it does not update the runtime that it's working from. It just updates any changes you made to the script. So that's why it's faster. Now, if you want to save your work while you're connected here, it's in load save. So the load save button allows you to download a project hex. Before that, you want to name your program. Okay, once you've given it a name, hit load save, and then download project hex. And then you'll get a copy down there that appears in your downloads. And if you want to do an earlier hex file, I'll just refresh. Okay, so here is the earlier hex file. So I'm going to download it. So now basically you can, in most operating systems, you can just drag and drop a hex file right onto the editor pane, and it will open the code, open the Python script that the hex file contains. If you have any trouble doing that on your computer, I do know of one Mac in the world that couldn't do it. You can hit load save and then browse for a file. And then you can go to downloads and grab whatever file you need. So that's your backup if just dragging and dropping it onto the editor doesn't work. Now, one cool thing here is the serial terminal. So I'm just going to whip out a modification to this. So I'd like you all to modify this code with me. On line 7, let's stick a hashtag in front of display.show image.heart. And then on line 6, give you a second to get that hashtag in there. How are we doing? All right. And again, shout out to stop me. Then on line 6, let's replace display.scroll with print. Now, when we run this, it's going to look like your microbit isn't doing anything. And let's change the sleep to from 2000 to 1000. So now we have print hello world and then sleep for 1 second. And then if you're not connected, hit connect, choose your microbit, and then flash. And it'll look like nothing happened until we hit the open serial button. Okay, how are we all doing? Good, good. So this is a way to send serial data from your program to the terminal. And when you close serial, you're back at your program. When you open serial, I believe it restarts the program. You can always hit this send Control D to reset, and you can see that it started over again. I'm going to actually just make a quick modification here. Okay, so we're printing the text n equals, followed by a comma, and then it's going to display the value of n. That's how print statements work. And I'll show you how to look that up in just a little bit. So there's n equals 0 and n equals n plus 1 inside this while true loop. So this is something where it's going to do this and then that, and then this. It'll skip that, then this, then go back up to the top and repeat again, repeatedly adding 1 to n. And so flashing that and then opening serial will start you counting. And if I reset it, notice that it restarts at 1 again. So this is the reset button. You can also open REPL, and I forgot to look up what REPL stands for. Let's see here. Let me see if I can remember it. Can anybody remind me what REPL stands for? I never remember. Read, evaluate, print, loop. Okay. So this is REPL. Whenever you see these three little greater than signs, you can type in a statement like print hello, and it displays hello. Or you can say something like print, I'm just going to say hello again. But then we can say n equals 0. Okay, it's happy with that. Print n, oops. And it printed 0. Print n times 20. That's not going to give me anything other than 0. N equals n plus 1. Print n times 20. Okay, there we go. So this is another tool that can be used to just, if you're talking with students about examples, is if you have just a quick what if scenario, you can go into REPL, and then you can reset to go back to the main program. So that's something that's there. Last but far, far from least is help. Documentation. So if any of you are considering Python for your students, this is a set of basic tutorials that allows you to play with basically all of the different microbit features in a Python way. So here is an example program from microbit import display.show image.happy. I'll go ahead and paste that into the chat. And so there's a script you can paste into. You can copy and paste the script I just pasted into chat. First of all, we want to save our work. Load save, download project hex. Okay, and then once we're out of that, we could take that whole example and just paste it over what we have and flash it, and we should see a smiley face on our microbit. Are we good? Looks like you're still working. Okay, do we all have smiley faces? Awesome.
I do have to say, Andy, I do like this editor. I've never worked with the the Python microbit.org editor. So that's nice.
Yeah, it's very nice. But again, it's, the drawback of it is that there isn't simulation right now. However, I'm pretty sure that for that alpha version that we talked about, I don't know if they're going to do it, but I really hope they do. So right now it's still alpha. So here is the program, and I very much hope that they add their own simulation into it. I spoke with some of the folks at microbit.org, and it's a goal, but I don't know whether the version 3 release is going to have it or not. But I think some folks at Microbit are probably going to work really hard to make that the case. I just can't make any guarantees on their behalf. So that's currently, so the current reality is that if you want to simulate your Python, definitely go to the Microsoft version. But know that this exists because a lot of examples are available for it, and you can do a lot with it. And there's lots of, this is just the, so there's all kinds of good stuff in terms of lessons just in the documentation here. So this is just by clicking help. So here's the Python for monitoring how many button presses we have. So first of all, I'm going to put I'll put the page I'm at. Okay, button press page. Okay, then I'm going to paste in the script. And so you'll only want to grab these 3 lines here, starting with from microbit. Stephanie, Stephanie said something to me. You know what? I think I accidentally sent Stephanie a direct message. Okay.
I think you mean to send that link, that text out to everybody on the chat.
Yes, I did indeed. So let me copy this again. Okay, so I'm sorry about that. Here's the link of the page that we're at.
So Andy, the V2 doesn't mean it's with the version 2 of the microbit. It just
Oh,
means
that's a
it's
really good question.
Version 2 of their editor. So this would work with the version 1 microbit too?
Absolutely.
Okay.
Yeah. Yeah. So version 1.3, 1.4, 1.5. I've never played with anything older than a 1.3, but I believe that 1 point anything will work with this editor. In fact, as far as I know, unless you're trying to use a feature that the version 1 microbit doesn't have, like a built-in speaker, your code will work. I have not seen anything otherwise, but that it could be the case. Okay, so let's see here. Did I paste in your code? Yes, I did. Okay, so
Can I jump in real quick, Andy?
Yeah.
started using this editor. I got the cyber.org curriculum that I've been using with my before school club.
Oh, cool.
And, I love the functionality of it and how much more you can do as opposed to using the Microsoft editor. But the one drawback that I found is just as you said, there's no simulator. So like they can do stuff and then they send it to the microbit and it comes up with line error and they're like, what does this mean? What's going on? And so
Oh, yeah.
you have to go through and figure out why it hasn't compiled or why it's not running or look at the specific line. So yeah, without that simulator, it makes it difficult. And if they don't have a microbit, they can write all the code they want, but they can't test it out.
Yep.
To physically have it.
Yeah, so these are all excellent points. And again, it's weighing what you need to do. And so, some of you might end up using both. It looks like, Kurt, that you have been. Yeah, so, all right. Just
and you said this was good for like Python, and with creative coding, maybe the make code would work a little better for the beginners. But once you get past that, this seems like a great option when you want more of the text experience than just block based. So
Yeah, and what I have to show you later is sometimes you'll be herded into one or the other by virtue of which version the code is. um, so, so a quick tip, I don't know if anybody has shown okay, so, well, I'm just going to show you this. Let's insert a syntax error here. Let's misspell sleep. So now we're at slep 1000. Now, when I run that, it's really challenging to read that on the microbits screen. I'll just hold it up like so. So basically, the text is flowing across the screen, and it's a bit of a challenge to read. So if any of you are using this editor and have a coding mistake, and certainly pass this tip on to your students, is what you can do when you get a syntax error is instead of waiting to read it on the microbits LED display, again, so it was displaying here, we can see it in the MicroPython editor by simply hitting open serial. And then it will tell you in line 3, slep is not defined. So that can make it faster and easier to read to find out what the mistake is. And again, that's assuming that you have a microbit connected, because the microbit is actually finding that error and sending the information back to the serial terminal. So that's another use for serial, is to be able to just see quickly what your error message is. Okay, and I might have slowed down a little bit too much. Okay, so that is, and these are in the presentation. So here's the microbit editor. Here is the address of the microbit editor. Here is when you hit the help button, and here is the address of where it sends you when you hit the help button. And yes, this the web address for this is version 2, but that's only version 2 of this editor. It works on either version of the microbit. And then the list of things we talked about. Next up is, this one's new to me. Have any of you tried Classroom yet? Okay. It's really neat, but I've only tried it with a class of 1. But I'd like to try it out. So let's see if we can do something cool here. So here we are at Classroom, and I need to give you the address of this. Oh, wait, actually, I'm not going to paste that in just yet, because there's another address. The address is in the slideshow. It's classroom.microbit.org. And so what we're going to do is I'm going to make believe that I'm the teacher here and click the slide and have nothing happen, because I'm not at the page I want to be at. So going to the page I want to be at and closing a few of the others along that I've opened so I don't freeze my computer. Let's see here. All right, that ought to be enough. Okay, so I'm gonna disconnect here. So we also need to disconnect our we want to disconnect our microbit, our python.microbit.org editor. So make sure once you click disconnect, it should show connect and show an open link, and that's how we know we are disconnected. And actually, let's see. Okay, well, let's just kind of cross our fingers and hope this works. So here I am at Microbit Classroom. So I'm going to give my activity a name. Test Classroom. And we'll do this in make code. And sure, I'll use temporary local storage. Sounds good. And then launch Classroom. So now it shows us the 4 simple steps, which is 1, go to the editor, that's up here, and get some code going. Okay, so there's my code. What's step 2? Share joining details. And then I believe that's in the dashboard. Yeah. All right, so here is your link. Copy URL. So I'm about to paste this into the chat. Okay, so this is the link we're going to have you go to. And when you get there, you'll be able to select okay, I'm going to go incognito to look like a student. So I have an incognito version of Chrome. And so it's saying that our classroom name is Yellow Frog Sailboat Guitar. So the color spelled in the English version is yellow. Animal is frog. Transport is sailboat. That sounds like a lot of fun. Not yesterday in California, though. We had big rainstorms. And guitar. And then our pin is 750081. And these are generated every time. Welcome, Kurt. And then I'm joining too. All right, look at you all. Now, you probably don't see anything yet, and that's okay. We'll get there. So going back to the instructions, view your student's code. So you could be coding something, but I can also share with you. So if I go to my editor and so let's see, where is that? Share code with students. So here's my big long program that I spent forever the previous night developing, and I'll just hit share with students. And I can actually send you my hex file that way. And hopefully that appears for you. Did you guys get a hex file from me? Right on. This is a really cool system, isn't it?
Yeah, this is great.
Yeah, it's awfully fun. They did, you know, basically between the Microbit Education Foundation and Microsoft. Wow. They've got some really great resources. And then cyber.org, of course, and Parallax. We've managed to add some to that, and we'll talk about that next Monday. How are we doing for time? 20 minutes. All right. So, and then I can go in my dashboard and look at your code. Does anybody want to demonstrate what you have code-wise? Maybe modify the code. Okay, I'll do it. Let's see, where's my browser? Okay, so it says your teacher has sent you some code, and I'm going to say I want to use that code. And then here we are. And then so let's say as the teacher, I challenge the students to right-click that message, select duplicate, and then do a second message. Hello again. And then for some reason, I'm stuck because that mean old teacher is asking me to perform an arithmetic problem, but I'm stuck. And so I'm going to say, hey, can you help me out? Look at my code and tell me where I went wrong, because maybe in the math, I didn't do something right. So let's see here. Oh yeah, so like maybe I'm stuck with the absolute value of -5 because I can't seem to plug it in anywhere and didn't notice that it is showing me that I could potentially go to basic and display a number. All right, so here I am. As a student, I'm stuck. Now, as a teacher over here, I'll look at Andy number 2. And so here's my code as the student. And I'm definitely putting a load on my computer on this point. Oh, it did appear. And so, so now I can say, well, okay, looks like you have a problem. You don't know what to put that absolute value of -5 into. And then I could end up suggesting on my end, basic show number. And then math, absolute value of -5. Stick that in on start, and then say, all right, Andy number 2, take a look at this. And then over here in Andy number 2's screen on the right, I can say, all right, I'll use your code. And then there it is.
So we all got your code. And what if I don't want to use it?
That's a good question. Let's test.
I don't know what to do.
Yeah, neither do I.
Okay.
What happened? Okay, so if I send the code, all right, so my hope is that if you click outside of this dialog box, that it lets you not use the code. Let's try that. Ooh, wow. You're stuck. Okay, so I guess in this case, one thing I could do is if I'm
Yeah,
going
and
to
it just deleted all my code because I had no way.
Oh boy. Okay, sorry
Anyway,
about that.
well, that's okay. That's how we learn.
Indeed.
I
And
was-
so here's a few ideas. Okay, so when I'm sharing code, one thing you might want to keep in mind, I guess, is to I can uncheck all students or remove certain students. So Debbie, I believe I can click the X to say that I'm not going to share the code with you. And then another thing to do might be to send an all points bulletin. Okay, I'm about to share the code. So what you need to do is download whatever you've got because you want to take a snapshot of what you're working on before I hit that share code with students button. And I would guess that they're working on maybe improving the control of that a little bit. And also there may be like certain systems that you have in your school, like a network share folder where you could just drop the hex and your students can grab it.
So can you actually go to one of us and change our code, or can you just view it?
I think I don't think I can do anything other than view it. I think it's up to you. Let's see. If I go back to the dashboard and I look at Andy number 2 again. I think Andy number 2, I want to write a virus for him, but I can't. It's too secure. I can, however, share Andy's code with the rest of the group. Guys want to try that? Okay, make sure to hit save, everyone. If you want to save what you've got, hit download.
So when I don't see just the regular save button. I mean, download works.
Yeah, it's not a perfect system, but I still
Yeah.
think it's really cool.
Yeah, it is cool.
Yeah. You know, it certainly provides a way to share out code, especially if you don't have a network share, but you do have internet access. And then again, I also don't know in terms of IT protections of the classroom, if there's going to be any restriction on that. But here, I'll try sharing.
Did
Andy-
anybody see how to name it? Like, I don't see where I can name my file unless I just go in my downloads and rename it. But
Yeah. When you
I th-
download is where it allows you to in this particular classroom set, it looks like.
after you download, is that what you said, Ed?
Yeah, when you click download, then you'll
Okay.
set your name and the destination.
Oh,
Just
it
like,
was right there. I just, okay.
Well, let's see here. Yeah, so basically, this does seem like the kind of thing where you're just going to have to go to your downloads and say, the program that Andy #1 sent or something like that. Anyway, there it is. It's a resource. It might take a little. It might take a little practicing. And so what you can do again there is you can open, in my case, I just, oh, wait, whoa, cancel. Okay, so in my case, what I did was the little 3 dots in the upper right of the Chrome browser. I click those and then select an incognito window. And that allows me to appear as a separate entity. And so that's when I did the microbit join. And I pasted that in the incognito window. And of course, if you have a second computer, that's another way to do it. And if you have a second browser like Firefox or, I don't know how compatible these are going to be, but it's worth a try. You might be able to use a second browser or a second computer. But certainly with one browser, you can practice as a student just using the incognito window in Chrome.
And just so you know, I just realized I'm in Edge this whole time and it's been working. So
hey, that's
whole
actually really good news.
the whole entire session I've been in Edge. I thought I was in Chrome.
Oh, that's great news. That has not always been the case. We have had any number. Yeah, I think Ed remembers from the 2019. we were having challenges just getting Chrome to work, but they've really refined it over that amount of time. So, all right.
well, something I inadvertently, early on, Andy, when you asked us to change it and then share it out, I edited my content and I clicked, I finished up there in the top right of the student, and it kicked me out. In order to get back in, that's why you see my name called Ed again, is I was out and I couldn't get the interface again unless I joined again. So I don't know if that works, but
I think based on that, for the how do I feel, I'm going to answer with tears flowing here.
So you're saying if a student clicks I'm finished, they're finished.
It looks that way.
I'm looking at Andy's screen there and there's Ed and you see Ed again. And it when I got in, it gave me a chance to search for my name. But when I typed Ed, it didn't find me. Now I typed lowercase. Maybe I should have typed an uppercase E, but I did get kicked out. Well, I said I'm finished and I was out. Right. And it was like, uh-oh. So then I tried to get back. I even tried the back arrow, right? Thinking, okay, well, I'll just fake it. And that didn't let me.
So let me see then. I have a list of things like, well, so here is Ed. Oh, do you just want to like finish your Ed again and then try to come back as Ed?
Yeah. So I just did it again, right? I'm finished. And then I had the smiley faces and it says sign out. So it's like, well, there's not a sign out action, but there's nothing else I can see to get back in there. Right.
Yeah.
So I'm going to sign out. And I'm going to go back into the classroom again. I happen to remember those because I've done it twice now.
Oh, good.
Okay. Yellow frog, sailboat, guitar.
And then 750081.
And I had that memorized.
Wow.
Okay. So, cybersecurity stuff, right?
Yeah, there you go.
Or
yeah,
forensics.
once you can start remembering IP addresses, just hearing them once, that's yeah.
No, I'm not there. Okay, so I just searched my name, Ed, uppercase and lowercase, and I'm not sure when I type it in there. Let's see. I'm going to try it again. I'm going to click Ed and continue, and nothing, and Ed again, And continue. Oh, there it is. It caught my ed again. It didn't catch my first one though.
That is interesting. I'm going to try that too.
But I'm back
So-
into mine. So into the ed again. The ed I couldn't get back into. Oh, that was interesting. Maybe because I created a new student on this machine, maybe.
Yes, I
Oh.
do not know. Where's sailboat?
Should be right.
Sailboat guitar.
750081.
Continue. Yeah, it remembers me. It looks
Found
like,
yours.
yeah, I don't know. That
And maybe
there
because
may
it's a
be,
back arrow button. Maybe I goofed it up, but anyway.
or possibly hitting enter new name as opposed to
Well, I
doing
could
the search.
searching it first and it
Yeah.
didn't find it. So then I entered new name. And so I think once I entered new name on this machine, maybe it wouldn't let me go back to the first ed. So anyway.
Yeah. The other thing is, there may be just some kind of JavaScript hiccup in terms of leaving and rejoining that you managed to stumble across. And if you stumble across it again and can repeat the symptoms, I'm sure that somebody on a GitHub would be glad for the report. All right. So I think I have one more thing to show you all, and 7 minutes, 6.5 minutes to do it. So, I have a couple more things to show you. All right. The first is the curriculum links. I was just going to basically, since we've been in the microbit world, I was going to share that with you. So here we go in the chat. Paste. Oh, I think I just sent that to Stephanie again. She's been direct messaging me, but I haven't been able to see my chats. Try one more time here. Okay, there you go. And so so for microbit.org, they have a list of courses with some guidance that complies with usacode.org, CS fundamentals, courses C, D, and E, and then you can get to more details about that and read the full curriculum. And then those are the curriculum links, and you can go up on the left to see a lesson summary, and you can go down on the left to see the first lesson, and then they provide a lesson plan. So this is just a curricular resource. Some of you may have used it, others not. I said I plan to talk more about curriculum next time, but this was right here in the microbit microcosm. So, so there it is. Feel free to stop me with questions. The last thing I wanted to talk about today is the Make It Code It portion of the same website we've been at. So I'll copy that link. Probably talk a little bit more about that curriculum we just breezed by next week too. Okay, so Make It Code It. Paste. So this brings us back around to where I got the tiles that were on the intro slide. Some of you, I'm sure, have already made extensive use of Make It Code It. Now, we want to be careful because there's Make Code. That's the coding platform. That's Microsoft's code site, makecode.microbit.org. But there's also microbit.org/projects/Make It Code It. So like let's code, and then you can open your Make Code editor or projects. This is the Make It Code It right here. explore activities, and we're back to the link I shared out. And so it's all up here. This is where we've been all over today at microbit.org. And it looks like I've got about 3 minutes. And so I just want to point out that, like, if we look at this heart example right here, or this beating heart example, one thing I want to point out, since we've been talking about different Python editors, yes, you can open it in Classroom. That's what we just experimented with. You can open it in MakeCode. So that would be the block editor. So here is that project pre-written in MakeCode. Eventually, there we go. So now here's our beating heart in MakeCode, but it was pre-written for us. But you can also look at it in Python. This is where it gets a little tricky, because sometimes it's MakeCode Python, and other times, like here, it is microbit MicroPython, or microbit Foundation MicroPython. And so when you open in Python, in this case, it takes you to the familiar to that editor we experimented with second. And so that's just something, if you go the text route with some of these projects, just be aware that others might actually be, well, you can even narrow your search. For example, here's Python, but I believe that some of these are going to be the MakeCode Python, like DICE, I think I noticed was that. I may be mistaken here. Let's see what it says for Python. Nope. It may be that it's always microbit MicroPython here, but if you open it in MakeCode, you can always switch over to MakeCode's Python and use the simulator. So it's going to open by default So it's opening by default in blocks, but we can choose Microsoft's Python and then do the simulate and debugging type stuff. And so now, why would we want to open pre-written code? Well, it's because of step 3, improve it. So this is where the students are challenged to modify their code to make it better. And so, so the MakeCode portion of the site does definitely have its uses. And that's the make it code it. And I shared the link already, microbit.org/projects/make-it-code-it. And that'll get you to here. And you can search around for cool projects. And that's about all I had to talk with you about today, which is good because it's 4 o'clock and 20 seconds. Now, we can go ahead and continue to chat about things microbit, but that does conclude today's presentation, and I'll hang out here for any questions and answers, and I'll also be sending you an email, probably something about, here's some quick little thing that I'd like you to do to get ready for next week. It won't be any kind of intensive long homework assignment, but I might send out something to have you look at, or to have you sign into the Parallax and the cyber.org curriculum before next week. They're really quick. Both are quick. One's an email and a little bit of reading, very small amount of reading, and the other is filling out a form at cyber.org. And so that way we can all look at their curriculum together. Well, how'd that go, folks? Awesome.
It was great. Thanks.
It's kind of fun, huh? I hope I know for me, I learned a lot of new stuff just getting this ready for you all. Did you guys see some new things, hopefully?
Yeah, I saw some new things.
That's great.
Andy, as I'm looking here in that curriculum area that you just finished up with, I just clicked on the networks, and there's a lot of stuff about devices talking to each other, right?
Yeah,
you're
which
doing
is
that
beautiful
cyber
because of those
uh,
built-in radios.
and then the
Yes.
devices, yeah, the devices, all the different features that the device has.
Yep.
There's very specific stuff. So anybody interested in that kind of stuff, you can find specific items there.
Yes. And I'm pretty sure I will remember, but Ed, if I forget to highlight that next time, give me a little nudge as a reminder.
All righty.
I had some students who followed the communication tutorial and were able to send messages from one microbit to the other. It was really cool when they got that to work. And I wanted to see some more advanced things, but
Well,
I
check
don't
this
think we're
out.
ready for that.
Okay, so, but on the subject of advanced things, okay, I'm going to go to learn.parallax.com. I'll paste the link in a minute. Cyberbot. Okay, so actually this was something I was planning on talking about next time, but since you brought it up, we'll do a preview. Prerequisites like computer microbit talk is using that serial terminal that I showed you. But down here, there is with Python, right here, we start with radio data. And I'm sorry, radio basics and radio data are both primarily microbit exercises, even though they're part of the Cyberbot series. And so here, I'll copy those links in. So that's cybersecurity radio basics. The idea is we're setting up kind of a straw man by setting up the open radio communication so that we have a total network. And then there's also kind of a fun video. I wonder if I can get to it quickly enough. I'll show you. This is really awesome. Something that we did a little video on. I'm trying to get to it. There it is. I did a little presentation for a tour group last week, and I included the video, and they thought it was really neat. So let's see if I can find it for you. Okay, so what this is okay, what we have here is a classroom of, I think, 20 Cyberbot robots. And they all have microbits that are listening for radio signals. And then we have one microbit that is connected to the computer. And then it's running a script to radio transmit a speed and a time to go that speed. It's actually both wheel speeds, I think. And then it radio transmits it. And the result is pretty fantastic. Watch this. So he's typing in his left and right speed, and then the millisecond execution time.
Tokyo Olympics.
Yeah, that's right. They did some pretty amazing drone maneuvers that way, huh?
Or is this the water dance or whatever it's called?
Yeah. Yeah, I thought you might like that. Oh, and then the last slide I forgot to mention. Shucks, everybody's gone now probably. The last slide is a summary of the important links that we talked about today.
Awesome.
And there we go.
All right. Thanks, Andy.
Well, thanks for coming, everyone. And then
Thank you.
anything else before we sign out then?
I think we just had
See you next
one.
Monday.
Yeah.
Yeah.
I think we just
See-
had one of the folks that signed up didn't show. So, but that's pretty
Okay.
good.
Yeah, so I am going to stop the recording now.